Hello dear friend, the aim of today is just to do a Labview program that will make us to hit the sound and generate the sound which is running like this. Now here that we are generating the sound which is give us a sound alternating with a frequency which is changing. So, and it is give us the sound which is not really cool. So let us introduce some timings to understand the terms or to understand the concept clearly. So start the timing which is like of 1 second to hear clearly the output sound, which is 1000 milliseconds, which will give us the sound which is very clean like that. This project is to produce a sound which will help us to give an alarm. It means to create an alarm of a system running under Labview. As you know, the aim of Labview is to control and to create a virtual instrument, but also to create an interface which will help the user to get in contact with a learning system. So without delay, let us start coding graphically in our program. First, I'm going to create another new sub-VI, then click Ctrl T to back to get our windows, which is a block diagram and a front panel which will allow us, of course, to create a sound. So as we know, the sound tone depends on the frequency and also depends on the volume of the sound. That's why I'm going to bring a numeric control which is knob, and let me click Ctrl plus to zoom in and change the value to 100 and rename this as volume. By ending like that, let me click to zoom in here and bring the graph, means waveform chart, that will help me to get rid of the graph. Call it sound, or simply call it a wave. It means where we will be reading the wave of our sound. Let me zoom this so that it may fit the vision spectrum, and then come back here and create a while loop in which our code will be running inside. Let me put this tab over here, and then through generating sound we will be needing the sound output sub-VI that will help us to read, it means to interpret the sound, to put the sound generated by Labview on the output speakers. It means the computer speakers. Come here to sound, then back to sound here, then pick the sound config, where we configure the source of our sound. After, we need a sound output. Which is a set volume, which will enable us to, of course, to control the volume of the sound. Come and join. It means wire up the volume control. By default, it is reading in integer. Then task ID to task ID input our volume. Yeah, just like that. And then next we are going to simulate a signal which will give us the output sound. Come here to express, then signal analysis, and then pick up the simulation of the signal. Yeah, you see by default they give us like that, but let us take sample rate, which is more common and which is 44,100, and don't let this be like it is, but set it to 5K and make it run as faster as possible. Then change this to frequency, because we will be needing to enter inside the frequency. It means to set the frequency which is an integer. So click here and then turn it to a frequency. By default it comes like in orange, which will help us of course to interface it with an integer. It means we control the frequency by the source, which will give us the readings in integer. Connect error out to error in of our signal. Left click to clean up this wire to accurate. Yeah, and then next will be to set the output. It means we are going to write the sound generated on the speakers of our computer. Come here, join the sound, and then pick up the sound output, which is right. I'm going to write the sound which is generated from, of course, the sound simulation. Join the task I did with that in sound right, and then you are going to join this with the waveform generated. We will use it to write the sound, but it should be manipulated and be changed so that you can get an accurate result. So come here and join the express and go to sound manipulation and pick up this. This will allow us to change the output from complex wave to the single waveform. And if you come here, go to visibility and turn on the caption, you will see that it will convert from dynamic data to a simple data. And then connect the output of signal simulation, and the output of that conversion will be automatically fed to our waveform, which will help us to see what is really running inside our circuit block diagram. After the compression of that, we are going to clear the output, sound output, and then take the VI, which is sound output clear. We will clear this to there and connect error out to error out, and then here we are going to handle the errors there by coming in dialog, user and user interface, and then pick up the error handler, put it there like that, and then connect. I think you are almost finished, but remaining to create a button that will allow us to stop the while loop as we wish. So things is already. Let's try to simulate it a little bit. Just the volume. Let's still a problem. Let me see if I can handle it. Alright, the problem is obtained is that I'm no longer finished this stuff. I should come here and make some configuration that will enable us to select. Of course, here is the device ID, and for us the default device ID is 0 because there is no other device needed here. And sound format, we will use the sound format as created from this part. It means from this sound simulation system. And remember that we use a 44100, and the remaining will be still like that. And then come here to sample, create a constant there, and we let it like that. Create number of sample per channel, and remember that from our signal simulation palette we use 5K. And we rate it like that. For the part of the frequency, of course we will be controlling the frequency by an integer data type. By default we are going to use a random number generator, which will help us to produce a difference number. It means to generate the number, of course, as seen in the video before this, that produce the number between 0 and 1. It means 0.5, 0.05. It means the range which falls between 0 and 1. And then multiply this stuff with, of course, we are going to bring a multiplication palette, wire it like this, create a constant here, create a constant here, create a constant which is like, let us use like 10K, so that it will fall in the frequency which is in the range of human hearing. As we know, the frequency that a human is able to hear, as proved by scientists, that the human hearing range of frequency lies between 20 Hz and 20 kHz. So that's why we multiply the number from random number generator by 10K, so that we will fall in the range that human can hear. And then use the output of that to generate the frequency which our program depends on. Then come here, create an indicator which will show us the frequency. As I told you from the starting of this video, this will help you to generate the tone of the frequency that you may use while you are creating an alarm audible signal in your virtual instrument. Should be creating an indicator there. You see that we are already done. Come in. You have front panel, then control zoom in to increase the size of your indicator. Put it down and rename this to frequency. rename this to frequency. Okay, I think we are about to finish the session. Let's simulate again to see whether we are reaching the target. Yeah, the error for the running failure is obtained is that you forget to wire the sound output to right. Yeah, you see that we completed the operation. So then let us run it again to see the output. You get that there is a noise in our output, means there is missing. It is missing the things of order which will depend on the timing. Let us bring the timings of 1 second. And then create a constant which will allow us to put it in the timing and use 1000, which is of course 1 second. That the value there is in millisecond. Then hit run. As we are about to finish, let us make things like decoration that will give the user a good interface. Bring this button down and click Ctrl+ to zoom it a little bit. Yeah. And of course, come to decoration. Choose the decoration according to your wish that will fit your eyes and create a good interface for you. Yeah, come to view, then tool palette to change the color. Let it to as like that. Drop the color there, and then close the tool palette. Click Ctrl+Shift+J to move it to back and get what is needed. And of course we are going to bring another decoration. All of this is to get a good interface for the user of our virtual instrument. Change the color. Let's make it like green. Then turn off the tool palette. Select it, then click Ctrl+Shift+J to bring our content back. Yeah, you see that we already finished to get a virtual instrument that will produce the sound according to the frequency generated from the random number. So let me run again to see whether our virtual instrument is running well. That according to the frequency obtained in this frequency generator, you will be able to understand the tone and create an alarm, an audible alarm, which will help you to bring the attention of the virtual instrument user. And according to the readings obtained here, you can make a continuing sounding system of the tone you wish. So as heard in this video, also you can adjust the volume. Let me run again and try to adjust it. As heard in this video, also you can adjust the volume. Let me run again and try to adjust. So I hope you enjoyed the video. If it is your first time on this channel, please click subscribe. And my name is Alex Sera here, and the channel is called K2K YouTube channel. Ciao, bye.